Math Humans. We're going to do 2.5b today. We're going to be doing more work with our implicit differentiation. So our objectives are that we're going to continue working with implicit differentiation. That's pretty easy. So let's just jump in with our first example. And it says, find the second, ooh boy, derivative, struggling to spell today, implicitly, and then evaluate each derivative at the point -3, 4, and our function is going to be x squared plus y squared is equal to 25. So in case you don't remember what this equation is, this is the equation of a circle, center at the origin, radius equals 5. And so I want to know what the first derivative, so -3, 4, so let's say it's right there. I want to know what the first and second derivative do at that point, okay? So let's just start off. Here's my handy-dandy equation, and I'm going to start off with the first derivative. This is kind of a cool problem, okay? So first derivative, 2x plus 2y, dy dx is 0. 2y dy dx is a -2x, so dy dx is a -2x divided by 2y. The 2's cancel, so it's a -x over y. So I'm going to write dy dx is a -x over y. And then remember it said evaluate each derivative at the point -3, 4. So I'm going to go ahead and do that right here. So that's going to be a -3 over 4. And then if I write that answer politely, dx evaluated at 3, 4 is a -3 over 4. Okay? Bad math. Shame on me. +3 because it was a negative and a negative. So now I'm going to do the second derivative. So I'm going to write that dy dx was equal to a -x over y. And I could do the quotient rule, or I could do the product rule. So just to practice, I think I'll do it with the quotient rule. So my second derivative is going to be low times the derivative of the high minus plus high times the derivative of the low over low squared. Okay? So I'm going to simplify this to be a -y plus x dy dx over y squared. But remember, we just found dy dx. It's right here. So I'm going to take my derivative, -y plus x times a -x over y over y squared. So I'm going to substitute in the derivative that I've already found. To make my math life easier, I need to put these fractions together. So I'm going to multiply this fraction by y over y. So I get a -y squared minus x squared, there's the negative, over y squared. So my second derivative, and the notation is a little bit weird, is going to be a -x squared minus y squared over y cubed. Okay, so there's my handy-dandy notation. And then I'm going to evaluate that derivative at the same point, -3, 4. So my second derivative is going to be a -3 squared minus 4 squared over 4 cubed. And that math turns out to be a -25 over 64. So then I'll write it over here because I'm almost out of room. d2y over dx squared is equal to a -25 over 64. And that's when it was evaluated at 3, 4. Okay? So that's actually kind of cool. And this is a very common situation to have happen where I did a first derivative and then I substituted my work back into the equation that I came up with and then continued simplifying. All right, only 2 examples today. So for example 2, it says find the equation of the tangent line to the graph at the given point. So we're going to have this lovely equation, 7x squared minus 6 radical 3xy plus 13y squared minus 16 is equal to 0. And I'm going to do it at the point radical 3, 1. This is a really cool equation. I'm not going to tell you what it looks like, but I might recommend that you graph this in Desmos because it looks really cool. Okay, and then just for the interest of time, I'm not going to show you that, but I might say that you do it just to see what happens. So now I'm going to start my derivative. I do notice that I have the product rule and I have implicit. So my first derivative is going to be 14x minus, this is the product rule, the first thing, that's a 3x times the derivative of the second, plus the second thing times the derivative of the first, which is a negative 6 radical 3, plus 13 times 2 is 26y to the first, dy dx equals 0. Okay? Clean that up a little bit, and I have 14x minus 6 radical 3x dy dx minus 6 radical 3y plus 26y prime equals, oops, forgot the dy dx is 0. And again, I'm going to factor and move at the same time. So I'm going to factor out my dy dx. And I'm going to get a negative 6 radical 3x. And then this guy plus 26y. And then taking things to the other side, minus 14x. And then plus 6 radical 3y. Remember, we're solving for dy dx, so dy dx is going to equal the right-hand side, 14x plus 6 radical 3y over negative 6 radical 3x plus 26y. Whew! There's my derivative. And it says find the equation of the tangent line, so I'm going to evaluate that derivative at radical 3, 1. Remember, this is just all little steps to the end. We're not quite there yet. When you do this math, you're going to get a negative 14 times radical 3 plus 6 radical 3 times 1 over a negative 6 radical 3 times radical 3 plus 26 times 1. When you do all that math, you get a negative radical 3, and that is dy dx evaluated at radical 3, 1. And there is my slope, and remember that's the slope of the tangent line. So now I'm going to do my point slope is equal to the slope of the tangent times x minus x1. So y minus 1 is going to equal a negative radical 3 times x minus radical 3, and I get y is equal to a negative radical 3, x minus radical 3 plus 1, and that is the slope of the tangent line. Whew, that was entertaining. All right, and technically it's at the point radical 3, 1. All right, my dears, that's it for today. That was kind of cool. Thanks for doing math. See you soon.